Is that water?
Yeah, it is.
It's liquid.
I don't care.
You guys want another demonstration? You tired of doing problems? You want to take a break from problems? Want to do a demonstration?
Yeah.
Sure.
All right. There we go. It's break time. You guys are working so hard. All right. Here we go. This is your usual ball and hoop type demonstration. Okay? I've got a ball. I've got a hoop. The ball and the hoop. The ball fits through the hoop. It fits too well through the hoop. Why does it fit so well? Let's try it. Maybe I've never done this one. Let's try this guy. Ball fits through the hoop. It's your ball and your hoop. Your ball and your hoop. Right? So if I heat up the ball, the ball will expand. It will expand because kinetic theory says the atoms are moving faster, right? So they're moving back and forth, but they actually spend a little more time farther apart than they do closer together, and so as they move faster, the average distance between the atoms spaces out a little bit more. So the object itself just gets larger, okay? And this is called thermal expansion. So when you look at bridges, you see those big, look like the jaws of death on bridges. Those are expansion joints that let the bridge expand without collapsing into the river. This is massively important to read. It's okay, we need a joke. Did I tell a joke about the guy driving through the country?
No.
Runs over a cat. Did I tell that story?
No.
It's tragic. Don't laugh at it. This guy's driving through the country, runs over a cat, just kills it. Just flattens that kitty, right? And it's sad. That's very sad, right? So he walks up to the farmer's house and he knocks on the door. The guy comes to the door. The guy says, "I'm so sorry. I just killed your cat. And I feel like I should replace your cat." The guy looks at him. He goes, "How are you sure it's my cat?" He goes, "What did it look like?" And the guy goes, "No. Before you hit it, what did the cat look like?" He goes, "No, seriously. I know it was your cat. It's like a compilation of dead cat jokes. I know it was your cat. I saw it come off the porch of your house. And, I'm so sorry. I feel I should replace your cat." And the guy looks at him and says, "How are you at catching mice?" All right, here we go. Are you ready for this? Is the ball going to fit through the hoop?
No.
No, the ball has thermally expanded and no longer will fit through the hoop. So we have to cool the hoop down, or the ball down. Look at that. If I cool it down enough, it will again fit through the hoop. Yes, there we go. Now, let's try. Now let's try the heated hoop controversy. This is very controversial. Because if you think about it the wrong way, you might think that heating it up makes it so the ball won't go through the hoop. Okay, so there are two ways of thinking of this. One way of thinking about this is I'm heating the hoop, and so the hoop is expanding into the hole, making the hole smaller. The other way of thinking about it is that the hole in the hoop is part of the hoop. If we make the hoop bigger, the hole gets bigger.
So which way does it stop?
So what's correct? Is the hoop going to get bigger? Or is it just part of the object and gets bigger along with the object?
I think it'll expand into.
Or is it
both ways?
going to expand into the hole
So
and make
yes.
the hole smaller?
The answer is
know.
yes.
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 Miranda's
Expand
looking
into
it
the
up
hole,
on
but it'll
on,
be expanding.
on Wikipedia. Don't be doing that. Here you go. Does anybody want a unique
Sorry.
brand on their forehead? Okay, here we go. Are you ready for this? Okay. Does it fit through? It fits through better than it ever did, yeah. So the hole is part of the object, and so dancing around in it, there's so much room. Okay? So the hole is part of the object just simply gets larger. Now, back in the day, or even now, when we need to join metal by welding it, okay? When we weld metal together, have you ever heard of cold riveting? Yeah, there we go, right? So you make the rivets cold, the rivets fit into the hole, and then the steel, the iron, is heated up to a really high temperature, the stuff with the holes. So you heat the hole up so the hole's big. You cool the rivets down so they're super cold, right? They just barely fit in there. And then, what happens? Yeah, the rivets expand and the hole gets,
Smaller.
when it cools down, the hole gets smaller, doesn't it? Right? And so it clamps down on the rivet, and the rivet is not easily removed. Right? The other thing they do is, of course, they round off the rivets on either end. All right. Here we go. I have at times forgotten to cool this thing down. It's still hot even though it doesn't look hot. I'll put it away and be like, why is there smoke coming out of the box? All right. Ooh, it's still toasty. Okay. Here I have a bimetallic strip. That means it has two metals. It has brass, it has iron, brass, iron, brass, iron, brass, iron. Okay? Brass expands faster than iron. Brass expands faster than iron. Iron doesn't expand very fast. So if I put the brass on the bottom, what is going to happen to the bimetallic strip?
It's going to curve upward.
The fast expanding side is on the bottom. Watch. Check that out.
That's incredible.
It's impressively fast.
So
And very visible.
you can use bimetallic strips to detect temperature, can't you? The hotter it is, the more it's going to be like that. So when you look at, if you've got one of those giant dial, and when I was doing your
My thing,
your
yeah.
thing,
Yeah.
the data thing,
Yeah, my
you
data.
said what kind of thermometer? I was going to say large dial outdoor thermometer to measure my temperature. I thought that would be funny.
Yes.
Okay.
Other-
When you see those large dial outdoor thermometers, look in the middle and you'll see a little coil of stuff. What do you suppose that coil is of?
A bimetallic.
It's a bimetallic strip, and it will, I think, coil up when it gets cold, or I don't remember. It does one. It uncoils or coils, depending on which way they've got it in there. And the needle moves around like that. So there we go. And then we can, of course, put it in the cold water. That gets it right back in its ordinary shape. All the guys are like, yeah, I can relate.
Wow.
Sorry.
Kid?
That was an off-color reference to
I can't believe you just
a
said
certain
that.
anomaly of male anatomy. Physiology, right? Very good. Okay, so back in the day, one last little nugget of knowledge. Excuse me. Back in the day, we had an old house. It had an old, cool-looking thermostat that we got very tired of after a while. Can I interrupt? And this very cool-looking thermostat had a vial. It had mercury in it. It actually had mercury in it. And basically it was a bimetallic strip. It had a thing of mercury in there, and there were two wires at this end. There was a lump of mercury on this end. Mercury is a metal, but it's liquid, yes? Mercury conducts electricity, we know this, don't we? Okay? So when this thing would get cold, when the bimetallic strip would get cold, it would actually kind of raise up like that. When it raised up, that mercury would roll down to this end, touch those two wires, and it would turn our furnace on. Yeah? Nowadays, we've got like a little computer in our house, a little thermostat that has these little thermal sensors, and it's programmed to learn how long it takes to get the house up to temperature in a certain amount of time. And all this like that. No, not our house. Not our house 20 years ago. And this is circa 1930s technology. All right, I am done with those demonstrations.